All right. This is exercise 2 from lecture set number 2 of the fall 2024 stat 252 lecture set collection. In this exercise, we will be working through a t-test based off the following information. So according to Communications Industry Forecast and Report, the average person watched 4.55 hours of television per day in 2005. In 2015, the average amount of time spent watching TV by the individuals in a simple random sample of size 20 was 5.87 hours, with a standard deviation of 2.297 hours. At the 10% significance level, did the data provide sufficient evidence to conclude that the amount of television watched per day in 2015 is greater than the average reported in 2005? All right, so this is a upper tailed test about 4.55. So the first thing we have to do are check the assumptions of the procedure. So we are told in the description that it's a simple random sample. And then the second assumption is normality of X bar. And we are given a QQ plot here. We can see that the points on the QQ plot follow the theoretical line quite well. There's no obvious departure or curvature. So we can say, yes, QQ plot provides evidence of normality. Right, so those are the assumptions of the test. And now we can work through the steps of the test directly. So the null hypothesis will be that the mean is less than or equal to 4.55, and the alternative will be that the mean is greater than 4.55. The test is going to be conducted at the 10% significance level, and our test statistic will be a t-value because we only have sample level information. So we will have 5.87 minus 4.55 divided by 2.297 over the square root of 20. And this gives us 2.570. That is the test statistic for this problem. Right. So on the fourth step, we can take the critical value approach or the p-value approach. So if we take the critical value approach, we start by sketching out our student t distribution, which is shown here. Okay, we're going to mark down our test statistic, which is 2.570. And this green shaded area here under the curve above the axis represents the area of the p-value. Okay, or sorry, it represents, yeah, the area of the p-value. I just did the p-value problem, sorry. So we'll just make a little adjustment here. I started with the p-value. Okay, so this represents the area of the p-value. Our p-value statement for this problem will be the probability that t exceeds 2.570. So our degree of freedom for this problem is going to be the sample size minus 1, which is 19. So if I flip over to the student T table, I mark down 19 degree of freedom here. The test statistic is 2.570. Okay, so 2.570, you can see, is between these two quantities here. So that means that my tail area is going to be between these two quantities here, 0.01 and 0.005. Okay, so I can say, since 0.005 is less than the probability T is greater than 2.570 is less than 0.01, then 0.005 is less than the p-value is less than 0.01. Okay. Okay, now if I take the critical value approach, so I'll just borrow this curve here. So here, I'm going to mark down, or I'm going to sketch the area that corresponds to my critical value. So this is the rejection region. This is a region of size 0.10 because the significance level is alpha 0.10. So that means that I have a test statistic on 0.1 and 19 degrees of freedom. Okay, because it's an upper tail test, as we can see from the alternative, all of the area for the rejection region is in the upper tail. So that's why T subscript 0.1, no manipulation of the significance level is required. We go back to our student T table. We're going to match 0.1 to 19, and that makes the critical value 1.328. So I have 1.328 here. My test statistic is 2.570. So that's going to be over here somewhere based off of this sketch. So we can see in this case, the test stat gets into the region. So on the fifth step, I can say, if I take the p-value approach, since anything between 0.005 and 0.01 is less than 0.1, the p-value is less than alpha, so we can reject H0. Similarly, if I take the critical value approach, I can say, since the test statistic is in the rejection region, reject H0. Okay, so now I can conclude by simply summarizing the result of the test in its traditional format. So again, we were testing that the average amount of time spent watching TV in 2015 was greater than that in 2005. We have evidence that this is true. So here we can say, at the 10% significance level, the data provide sufficient evidence to suggest the average amount of time spent watching TV in 2015 exceeds 4.55 hours.